including human cell therapies, studying diseases, developing new drugs and screening drugs. Now, if we were to use embryonic stem cells for human therapies, you have to think, well, the therapies, the diseases we're going to use them for, we're going to want to do the therapy and fix people for 20 to 30 years. Now, in that case, we've got to think about immune rejection. Now, if you look at people who've had heart transplants and things, they get over that immune rejection by suppressing the immune system. So if we were to carry out lots and lots of stem cell therapies, would we want everybody walking around with a suppressed immune system and catching lots of other diseases? So one idea was we could make what we call autologous or personalized stem cells. So you can take a cell from an individual, go through, or you can, if you want to, you can add in genetic correction of whatever's wrong with that person at the same time, go through the nuclear transfer procedure, make an undifferentiated stem cell line, and then differentiate it in vitro or not, and put it back into the same person, and therefore it should not be rejected. The other use of this is also to study diseases where we don't know what the cause is. So we can take a cell from a diseased person, for instance, Lou Gehrig syndrome, which is a neurodegenerative disease. We can do nuclear transfer, make a stem cell, and then we can watch the development of that disease by differentiating it into a neuronal tissue. So we can study the disease in a dish and look at developing therapies for it. So I'll leave it there, and I hope I've given you an insight into some of the uses of cloning technology and stimulated to think of some of the ethical problems we might have. And I'll leave it to Dolly to say goodbye, because these are all Dollys who are alive and well at Nottingham University. And they are 5 years old in July, so they're doing well. We made them 5 years ago. Using a much improved technique that we developed at Nottingham. So I'll say thanks very much for listening, and I'll happily try and answer any questions.
Thank you so much for an interesting lecture. W takim razie teraz mamy jakiś czas na dyskusję, na pytania. Pytania będą tłumaczone dla profesora z polskiego na angielski, więc można śmiało zadawać je w dowolnym z tych dwóch języków. Moja koleżanka będzie podawała mikrofon. Proszę mówić do mikrofonu, żeby też tłumacz miał możliwość tłumaczenia tego, co będzie mówione. Także kto ma ochotę zadać jakieś pytanie, jakiś temat poruszyć, proszę o zgłoszenie się i Beata podejdzie z mikrofonem. Śmiało.
Hello, I'm Błażej Grygiel from Radio Talk FM, and I'd like to ask you a question whether there have been studies on the behavior also of those dollies, and are those behaviors rather individual, or would you say they behave in almost the same way? Is it possible to make a research on that?
Okay, there have been some studies. Well, people have asked me if they can come and study my sheep, but let's talk about it. There was a study done with a flock of transgenic sheep, and after 6 months sitting in the field, the person studying them decided they behave just like any other transgenic sheep. Now, Dolly was a very special sheep because sheep are very friendly. If you have a pet sheep, it will behave like a dog. And Dolly was a very pet sheep, and she used to basically beg for food, and lots of reporters came and wanted a picture of her, so they'd all give her food. So every time she saw a human, she would run over and demand food. Now, the first Dolly we produced at Nottingham, which unfortunately died before we perfected the technique again, and died of different things to Dolly, was also heavily petted by the staff, and it used to live in the animal house. It used to run around the corridors and sit under the desk in people's offices, much like a dog. And so the personality, you know, is dependent very much on how you treat the animal. These animals are kept with a group of other sheep, and they're less human contact. They're more just like normal sheep. They behave just like normal sheep. They run away basically when people come.
Dziękujemy. Kolejne pytanie.
Sneer Boniel from the American School of Warsaw. A question about how can we use, if at all, how can we use cloning techniques to increase neuron production or intelligence?
Well, neuron production, I'll take that one first because, you know, people are now, a lot of neurodegenerative diseases people don't know about. People are looking at, and so I have a student actually trying to study this on a basis of literature-based, okay? The way I look at it at the moment, we might be able to use stem cells for neuronal damage, although Geron, who had gone into clinical trials, have stopped. They said it was too expensive. I've got a feeling it possibly doesn't work. In terms of increasing neurons in people, I'm not sure we're going to be able to do that. You have to do that at the fetal stage, I think, you know. So you'd be back at the fetal stage, and probably doesn't even need stem cells. You need to just stimulate neuronal tissue. But intelligence isn't related to the number of brain cells you've got anyway. It's how they work. Because we've all got about the same number of brain cells. So the fact is, it's how your brain is trained, a lot of people think. And there are lots, you know, so it may be so it's basically different biochemistry that we don't understand. It's not due to the number of cells in your brain that gives you intelligence. It's due to how they work. And we're beginning to understand more of the interactions of different parts of the brain and more of the chemicals that are involved. In which case, it's probably just a drug regime rather than a stem cell regime. But I mean, whether we should be doing that is another matter. But that may have great things for people with other brain disorders. If we understand the interactions and the chemicals involved, we can maybe stop people having fits and lots of other things.
Dziękujemy. Prosimy o pytania. Zapraszamy.
Hello, I'm Karolina Kwiatkowska from Bator Lower Secondary School. And do you think that cloning can be a natural antidote for death?
No. I personally don't think it's an antidote for death. I'm opposed personally to human reproductive cloning because there are no reasons for it. I can say that cloning in terms of using stem cells to help treat illnesses which may prevent death, I support, but I don't think bringing people back after they're dead is helping prevent death. And you wouldn't be the same person anyway, because we go back to this nature-nurture debate. I mean, there was a company in California suggested that if your religion was such that it prevented you having an abortion, you could have the abortion, freeze the fetus, and then when you wanted a baby, you could go back and have the same baby. So therefore, you had never had the abortion in the first place. Now, I don't agree with that use either, alleviating people's consciences. So I don't support reproductive cloning for any reason, okay?
Dziękuję bardzo. Tutaj jest chętna osoba na pytanie.
Hello, Agnes Margot. Antidote to keep youth, maybe?
Well, you know, I think one of the things that may come out, not cloning, but stem cells, it's not cloning, you don't need the cloning. I mean, the cloning's not going to get your youth back unless you can think of a way of transplanting your brain into the clone. And I think there's too many connections there. Because there is a film made about that, actually, a long time ago, where they're moving people's brains to keep them extra young. So every 10 years you get a younger body to put your brain in. But at the moment, you see, you won't have any of your memories. Your clone would just be a sort of younger genomic copy. So it's not actually doing anything. But there are a lot of, I don't know about keeping youth, but a lot of health. Cloning of what, though? Its stem cells may help you stay healthier, but cloning per se, reproductive cloning, is not going to help for anything. Stem cells, embryonic stem cells, there are lots of other stem cells, and people are beginning to use stem cells for other reasons, which may actually help you live longer or you know, improve certain organs of your life. And so there are things working. There's just a trial that's been done in the States with using various heart cells where they've actually managed to improve heart function after a stroke. So that's quite good. I mean, I don't know if it's stem cells or not. There's a trial just gone on in the UK with burns victims where instead of doing a skin transplant, they've taken an area of skin, and they're not sure whether this is stem cells that are present in the skin yet or not, and they liquefy all the cells up and grow them for a couple of days, and then they spray them on to the burnt area, and effectively there's hardly any scar tissue there. So I think you know, cloning per se isn't going to help some of those things, but the fact that we've now learned that we can actually start manipulating cells more, which I think a lot was promoted by cloning, is allowing people, or giving them the space and possibly the funding to look at some of these techniques that years ago people have said it won't work. Now they're willing to give it a bit of a boost and help it.
Ciekawe, mamy pytanie tam z drugiej części sali.
Michał Niedźwiecki. Ja chciałem spytać, jakie są możliwości odzyskania wymarłego gatunku, jakiegoś zwierzęcia, na przykład mamuta, przy założeniu, że się udało odzyskać jego geny. Bo wiadomo, że ktoś takiego mamuta musi urodzić. Jakie są szanse, że...
Jedna chwila na tłumaczenie.
Okay. Some things, nothing's impossible, but some things are improbable. At the moment for cloning we need an egg basically from the same species. We also need an intact genome, and we also need a surrogate species to house the fetus in and go through gestation and give it birth. Now, people have suggested that mammoths and elephants are fairly well closely related. So if we could find an intact mammoth genome, there are elephant eggs available, and people have suggested that physiologically we're very similar. But I would say, based on numbers and time, it was pretty improbable at the moment. The same goes for a lot of extinct species. I mean, somebody wanted to clone, was it the Tasmanian devil, and the only one they had was in a bottle of formaldehyde, and I very much doubt that that's actually going to develop. However, somebody did find a mouse at the bottom of their freezer, which had been there for 25 years, and they managed to clone that. So that's why I say nothing's impossible. So it had been just lying, unprocessed, just thrown in the freezer, and the cells survived without any cryoprotectant for 25 years. So if some mammoth fell in a hole and was super frozen very quickly, I'm not saying it's impossible that we wouldn't find an intact genome. The other thing that people have suggested is if they could actually find an intact super frozen mammoth and it was male, they may find some cells in the testes which could substitute for sperm, so they could make an elephant-mammoth hybrid and then breed the mammoth back out of it, effectively, which they did with some other species, I'm not sure, some sort of zebra-type species. But I would say it's not very likely, in my opinion, it's not very likely at the moment, although it's always, I wouldn't say anything's impossible, because people said cloning was impossible, so we'll see.
Mamy kolejne pytanie, tu przy schodach wyżej w tej części sali. Myślę, że mam czas jeszcze na jedno, dwa pytania.
Hello, I heard that Dolly didn't live quite long because of those genetic material was taken from older sheep, and because the telomeres were way shorter than from younger organisms. So did you manage somehow with this problem?
Well, you see, this is another misconception that was put out by the press, that she would prematurely age. Dolly died of a lung disease, which is common in sheep, especially sheep that are housed together and drink water, and it's a virally induced lung disease. Lots of studies in sheep, pigs, cows, mice have shown all the telomeres are reset during development to the length they would have been, and there is no effect of that, so the telomeres are normal, and so there is no premature aging of these animals.
I kolejne pytanie tutaj przy schodach z tej części sali. Tak, śmiało.
Alexandra Czeka, I'm from Warsaw University of Life Sciences, and I have more like about problematic stuff. What was the biggest problem or maybe problems that you had with, well, because I'm studying biotechnology, and we as a